So question number 109 on the CP Practice Final Exam is the same question as 106 on the Honors Practice Final Exam. And the question says, how much energy is required to change the temperature of a 46 gram sample of water from negative 58.0 degrees C to the melting temperature? So we have 46.0 grams of water, and we're going to change the temperature. That delta means change in the temperature from negative 58 to the melting temperature. What temperature does water melt at?
Water melt at?
Yeah, what temperature does water melt at?
It's already melted.
Solid water is not melted.
Okay.
We commonly call solid water what?
33 degrees.
All right, 33 degrees.
Fahrenheit.
Don't use that. We're in a science class.
1 degree Celsius.
0 degrees Celsius.
No, because that's freezing. So
It's also the melting temperature. The melting temperature and freezing temperature are the same. So the change in temperature to melt our water, or get it to that melting temperature, change in temperature is a positive 58 degrees. We're going up in temperature. We're going to go from negative 58 to 0. So our temperature is going to be 58.0 degrees C. That's our change in temperature. Okay? All right, so what we need is an equation that will allow us to figure out if I have the mass of this and this temperature change, how much energy is required. Well, that equation is Q, stands for heat energy, equals mass times something called specific heat times the change in temperature. Now, if you're in a CP class, you'll find that equation right here on your test references. If you're in an honors class, you're supposed to have, well, you'll also have it on your references, only your CP will be just a lowercase c. Okay? What we need is the specific heat for ice. That's the number we don't have. We have the mass, we have the change in temperature. What we need to know is what the CP is. Okay? And that's also on your test references on the front page. CP is the specific heat. So we need to find which of these three specific heats we need to use. I have three specific heats for water. Which one do I want to use? They're all Q's. They all have to do with Q's. Which one do I want to use?
The first one?
That's liquid water. It says L.
So you use
The third one. There's our solid water right there. Okay? So our specific heat for water, we're going. Since this is a CP class, I'm going to use this one here because it matches the units we have already. We have degrees C down here. We have grams over here. So that's going to match up. Specific heat is 2.05 joules. That's how we measure energy over degrees C times grams. Now, honors classes have their set up a little bit differently. In honors classes, the specific heat, C, is equal to 2.05 kilojoules over K times kilograms. Okay? Works out the same way because the size of a temperature unit in degrees C is the same size as the temperature unit in K. So when the temperature changes, if it goes up 58 degrees in C, then it also goes up 58 K. All right? The starting and ending point on a Kelvin scale is different, but the size of the temperature unit in Celsius is the same as the size of the temperature unit in Kelvin. So the change in temperature in Kelvin or degrees C is the same. Okay? Now the freezing temperature of water in degrees C is 0. The freezing temperature of water in K is 273 K. So it starts in a different place, but the size of the change is the same. Okay? All right, so all we got to do is plug it in. Simple. Here's our change in energy. There's the symbol for that. Our mass is 46.0 grams. The specific heat is 2.05 joules over degrees C times grams. And the change in temperature in this case is 58.0 degrees C. Put these two over 1, and we use that same process we've been using all year long. Since Unit 1, we've been canceling units and species. Grams can cancel. I got grams on the top and bottom, just like X's or Y's in algebra. Degrees C can cancel. I'm only left with joules. Wouldn't that be nice to be left with joules? That's my joke, but nobody's laughing. Okay. Joules measure energy, and we know we've got it set up right. All we can do is math. All right, so we're going to get 546.94 joules. How many digits do I want in the final answer? Class, how many units do I want to have in the final answer? Underline 2 more because I've got these first 3 is the only 3 I'm going to keep. You look at the measured or calculated numbers. This is a calculated number and both these are measured. All those 3 numbers, which one has the least digits? They all have 3 digits. So we want our final answer to have 3 digits. So now we're ready to round off. We'll round it off to what? No, 547. That's 3 digits. There's our final answer. Okay? Pretty straightforward, pretty simple. So what about this over here? Well, it really is going to come out to be the same. I'll just show you really quickly how you set it up. So our mass is 46 grams. What we need to do is change our mass into kilograms. How do you change mass into kilograms if we have it in grams? What equality statement do I have or need to change grams to kilograms? Everybody needs to know this, whether you're in an honors class or a CP class. What's the equality statement that helps you to convert between grams and kilograms?
A kilogram is 1,000.
So 1 kilogram.
Is it 1,000 or 1,000?
It's 1,000 grams. So if I'm going to match the units that I have on the top here, what I put on the bottom here, I'm going to put this part on the bottom. And this part on the top. We can cancel the units of grams. And we get 0.0460. This has 3 digits. You need to be careful. If you just do this in the calculator, folks, there will be no 0 right here. If you put just this number in your equation, you're going to forget you need 3 digits. Keep up with your digits. Got it? Keep up with your digits. Everybody clear?
Yes.
All right. Huh? Keep up with the digits. Now that's the number of kilograms then. That means this many grams is that many kilograms. So 0.0460 kilograms over 1. And we're going to use this specific heat in an honors class. 2.05 kilojoules over Kelvin times kilograms. And our change in temperature has to be in Kelvin, because that's the unit we have on the bottom here. But what did I say about the change in temperature if it's in degrees C? How's that equal to Kelvin? I just said it. Please, come on, somebody tell me.
I'm out of it.
Were you not listening? What was I? Was I just talking to the wind here? Really? Come on. Listen again. You need to know this. Is everybody listening? While 58 degrees C is not equal to 58 K, the size of the temperature unit is the same. So if we're changing temperature, then it will be the same. Look. So if my final temperature is 0.00 degrees C, and I'm subtracting a minus 58.0 degrees C, okay, because I'm minusing, I'm adding, that's 58.0 degrees C. That's the temperature change, okay? But let's do it in Kelvin. Kelvin temperature for 0 is what? What's the Kelvin temperature? 273.15 K. All right, now I want to subtract that ending temperature. Okay, well that's 273.15 minus 58.0 degrees C. What does that come out to be? You have your calculator? Am I wasting my time here? Come on, use your calculator. Let's go. Tell me what it is. So the Kelvin temperature that matches 58.0 degrees C is 215.15. So the difference between those two is 58.0 K. So the change in temperature on the Kelvin and Celsius scale is the same. All right. So 58.0 K. Kilograms cancel, Kelvin cancels. We're going to have our answer in kilojoules. Plug it in, guys. Find an answer. Practice on the calculator while you have a chance. Oh, I got a zero in the wrong. I need 2 zeros after the decimal. 0.00460. Okay. Those are the same. Those numbers are the same. Those measurements are the same. A kilojoule. A joule is 1,000th of a kilojoule. A kilojoule is 1,000 times a joule. So that right there is it looks like it's 1,000th, but that means I take this and divide it by 1,000 to get that number. So you get the same answer.